Open your kitchen cabinet. There's a small box sitting there. White, ordinary, cheap. You use it for cakes, for cleaning, for bad smells, even for science experiments. But here's the strange part. Most people have no idea what it actually is. Is it a spice? Is it salt? Is it chemical? Is it natural? And here's the bigger mystery. If it's used for baking, why is it called baking soda? What exactly is soda about it? By the end of this video, you won't just know what baking soda is. You'll understand why this simple white powder quietly became one of the most powerful household substances on Earth. And once you see what's happening at a microscopic level, you'll never look at it the same way again. Before we break it down, here's something most people don't realize. The same substance that makes cakes fluffy is also used in fire extinguishers, toothpaste, cleaning products, medicine, deodorizing refrigerators, even in some industrial processes. How can one powder do all that? The answer is not magic, it's chemistry. And chemistry always leaves clues in the name. Baking soda's real scientific name is sodium bicarbonate. That sounds complicated, but let's break it into parts. Sodium, a mineral. Bi, meaning two. Carbonate, related to carbon dioxide. Long before modern kitchens existed, forms of this substance were found naturally in mineral deposits. Ancient Egyptians used similar alkaline salts for cleaning and preservation. But baking soda as we know it became widely produced in the 1800s, when chemists discovered efficient ways to manufacture sodium bicarbonate in factories. And once it became cheap and stable, it spread everywhere. Because it had one powerful ability, it could create gas on demand. And that changed baking forever. Before baking soda, bread and cakes relied mostly on yeast. Yeast works, but yeast is slow. It takes hours to rise. It depends on temperature. It can fail. Bakers needed something faster, something predictable, something that could create bubbles instantly. Because here's the real secret of baking. Soft cakes are not about ingredients. They're about air. If you can trap tiny air bubbles inside dough, it becomes light and fluffy. If you can't, you get something dense and heavy. So the real question isn't, what is baking soda? The real question is, how does it create those bubbles? Here's where it gets fascinating. Baking soda is a base. When it meets an acid, like vinegar, lemon juice, yogurt, or even brown sugar, a chemical reaction happens. And that reaction produces carbon dioxide gas, the same gas you breathe out. But inside cake batter, those tiny gas bubbles expand when heated. They push against the dough, and suddenly, the batter rises. That's it. Baking soda is basically a controlled gas generator. It stays calm and stable in the box. But the moment it meets acid and moisture, it activates. And here's the genius part, the reaction happens fast, which means you must bake immediately after mixing. Otherwise, the gas escapes before it can do its job. So baking soda isn't just an ingredient, it's a timed reaction. Now let's answer the name mystery. Why baking? That part is simple. Its most popular use was in baking. But why soda? This goes back to older chemistry language. In the 18th and 19th centuries, substances containing sodium were often called soda. For example, washing soda, caustic soda, soda ash, all of them contained sodium compounds. So sodium bicarbonate became known as baking soda, the sodium compound used specifically for baking. It's not soda like soft drinks, it's soda as in sodium. And here's the interesting twist. In some countries, baking soda is simply called bicarbonate of soda. Same substance, different naming tradition. The name stuck because it was practical, and practical names survive. There's something unusual about baking soda. It's a chemical. But people don't treat it like one. No one is afraid of it. Why? Because it behaves predictably. It's mild. It doesn't burn skin easily. It doesn't smell harsh. It doesn't feel dangerous. And psychologically, we trust substances that look simple, have been used for generations, appear in food even though it's a reactive compound. It feels natural. That perception made it acceptable in kitchens long before people fully understood chemistry. Trust helped it spread. Today, baking soda is everywhere. In refrigerators, it absorbs odors. Why? Because many bad smells are slightly acidic. Baking soda neutralizes acids. In fire extinguishers, it releases carbon dioxide when heated, helping smother flames. In toothpaste, it gently scrubs and neutralizes mouth acids. In cleaning, it reacts with grime and helps lift stains. So what makes it so versatile? It's balanced chemistry. It's strong enough to react, but mild enough to control. That balance is rare, and that's why the same white powder works in kitchens, hospitals, factories, and homes. Here's the deeper idea. Baking soda is stable until it isn't. It sits quietly as a powder, but introduce the right trigger, moisture, heat, acid, and it transforms. This is a powerful design principle in science, controlled instability, a material that stays calm under normal conditions, but activates exactly when needed. That's why it works so well in baking. You don't want gas all the time, you want gas at the right moment. And baking soda delivers it precisely when conditions change. So, what exactly is baking soda? It's sodium bicarbonate, a mild alkaline compound, a gas-producing reaction waiting to happen, a centuries-old solution to flat bread. And the reason it's called baking soda? Because it's the sodium compound that revolutionized baking. That small white box in your cabinet isn't just powder. It's chemistry engineered for timing. It's controlled bubbles. It's invisible air trapped inside cake. And once you realize that something so ordinary holds that much science, you start seeing your kitchen differently. Because the most powerful objects in your home are usually the quietest.